All right, so let's get started. We're officially doing week 4, and week 4 we're starting with repetition, which is the min, the max, the sum, the average. Those are some of the things we're going to cover. Any questions about anything we did so far? Any of the assignments, anything at all? Should be pretty straightforward considering how many hints I give you and the videos, right? But if you need more help, you're always welcome to email me. You're always welcome to come see me. You know the office hours. Oh, and then let's not forget the tutors and the STEM Center are available, right? Mostly in the mornings, 9:30 to something. That's when the person who took my class is there, but there's another person who supposedly has a computer science degree and it can help you with all your tutoring needs for this class. Okay, so since you don't have any questions, let's go look at week 4. And actually, why don't I do this? I'm going to go back to the previous week and I'm going to download this little lecture notes that I had from last time, so that I can give you like a little quick review. And here. Big enough? Can you see it? Okay. So, it'll be nice if I can move it. There we go. Alright, so some of the things we talked about last time were the Modulus Operator, right? And what we basically did was just found that it is the remainder operator. It tells you how many times or what number is left after you divide by something, right? So if you divide 5 by 3, right, 5 minus 3 is 2, right? And you basically always ask yourself the question, how many times does this number after the modulus operator fit into the first number? And it works out to the point where if you have any kind of a number and you do modulus 3 on that, then you would end up with either 0, 1, or 2, right? That's what we realized when we did this little example here. Okay, and do not confuse the modulus with the division thing, right? The division operator is different than the modulus operator. Together with this modulus operator, we can create a random number, right? If we just say rand, that will make a random number. Before we can do that, we got to do these 2 lines. You have to do the time no business. You could also do time no right here. All right, that would also work, but let's just leave it the way I had it. All right, so you basically have to write these 2 lines, and you also need to include time h, even though this thing says I don't have to. All right, so you have to include this, and you have to include this. So need this, oops, wrong language, need this for rand, right, and and srand, which is the 2 things you need to make a random number. Okay, so you need to give srand some kind of a value, some constantly changing value, so that srand will generate a list of random numbers, and then we're going to, from this list of random numbers, which is going to be a bunch of big numbers, we're going to reduce these numbers to smaller set of numbers. Let's say, for example, if I wanted to make a random number between 0 to 2, I would say rand modulus 3. If I wanted to make a random number between 0 to 10, I would say rand modulus 11, right? It's always 1 less than this value. Okay, if I wanted to go from 0 to 27, I do rand modulus 28. 0 to 5, rand modulus 6. If I wanted to do 10 to 15, then you basically start with this first number, whatever that number is, so it's 10 plus, and then you just take the difference between these 2 numbers and add 1 to them, right? So 15 minus 10 is 5, plus 1 is 6. Then you go do the same thing for, let's say, between 20 to 25. All right, you start with 20, And if you add 5, random number between 0 to 5 to that, then that will make your random number between 20 to 25. right? Same thing with 50 to 60 here, right? You start with a 50. 60 minus 50 plus 1 is 11. That's what this is, right? In other words, you start with 50 and you add a random number between 0 to 10 to that. And to generalize this, I gave you this little formula here, right? So you can make a variable min, make a variable max, and then the random number, let's say you want to make a random number between min and max, is min plus rand modulus max minus min plus 1. Right? So if you don't want to try to figure out the math every time, just use this. That's okay. Okay? We have been talking about relational operators. And what are the relational operators? Well, it's a way for your computer to check to see if two numbers are equal, or one is less than, or they're not equal, or greater than. Right? Those are the basic relational or comparison operators. The processor can figure out if something's true or false, but it can only compare two things to each other, right? So it can only compare one thing to another thing. Then a Boolean condition or a condition is what we create using these relational operators. What's a condition? Well, you check something to see if something is true or false. Okay? Yeah, I had a bunch of conditions in there, and I also talked about that the default way that C++ will show you true or false is 1 and 0, which kind of led to our Boolean data type, which is, well, that is the Boolean data type, which also led to our decimal and binary conversions, right? And we went over the different bits, right? How if you have 1 bit, you can only make a number between 0 and 1 in decimal. If you have 2 bits, you can make numbers 0 to 3. If you have 3 bits, you make numbers 0 to 7, and so on and so on and so on. And I showed you some kind of shortcuts in there. Basically, if you have 7 bits, right, the biggest number that you can make is 127, which is basically you just going in there and adding all these different numbers. So the first bit is a decimal. The biggest number you can make with it is a decimal 1. Second bit, the biggest number you can make with just that bit is 2. If you add these two, that's a 3. That's why you can make 0, 1, 2, 3 with 2 bits. All right? So, and when you fill all these bits right here and you add 1 to them, then the next number in binary, which is 128, is going to be just 1 less than this one. Okay? So that's that. So if we add the 127 and the 128, we're going to get a 255. Which is why these IP addresses, let's say I want to go terminal ping google.com. All right, so I'm trying to ping Google, and you're going to see that IP address of Google is this little thing here, right? So the rule for these IP addresses is, let's say Google is this, right? That's my IP address for Google, which means that I can just grab this number, go to my browser, paste this thing, and that's going to take me to Google. Okay, I don't have to remember that number because I can just say google.com and it takes me to the same place. If you want to know more details about how that magic works, take a networks class. Okay, so the next thing is, these things here. So this is 216. This is actually just so these numbers here, they can go from 1 to 254. Whoops. So it can be either 1, that's the smallest it can go, or it can be 254, right? The first address on the network is the 0, and the last address on the network is 255, but they're usually reserved for special purposes. So the actual numbers that you can have is from 1 to 254. Okay, just in case you're wondering, right? That's how the IP scheme works. So each of these here, this is 8 bits, 8 bits, 8 bits, 8 bits. Okay, so each of them is basically a byte. Okay, 8 bits, 1 byte, right? 8 bits is equal to 1 byte. Bytes, all right? So, going down, right? So a bunch of conditions in there to show you that the thing works. How you can use ifs and elses with these conditions, right? If you have a single statement, which is if you have a single line of code underneath an if, you do not need the curly brackets. If you're going to have multiple things like one cout and then another cout, then you have to put parentheses around that, right? You have to wrap them on parentheses. Okay, and then some hints in there for the different assignments that had to do with selection, right? So this is selection, ifs and else ifs are different ways for you to basically simulate intelligence in your program. So the possible situations, or you can have an if with some kind of a condition, and then in it you can have another if with some kind of a condition, right? And then in here you can have else if, right? Else if, and then some other condition, right? And then you can have an else if, some other condition. Okay, whenever you have an if inside of another if, the first thing you need to do is you start with an if, right? You cannot start with else if. Okay, another thing to watch out for is if you put a semicolon after an if. No good. Okay, don't do that because it will basically not work. It's called a do nothing if. Okay, should be a syntax error, but C++ compiler is not that very nice, so it doesn't give you an error. But if you do a semicolon, the if is not going to work. Another thing is if you have an else, the else is going to happen. The else does not have a condition, so you cannot have a condition for an else. The else automatically happens when the preceding thing is either true or false. I mean, whenever the preceding thing is false. So, what is the difference between having this and having it the other way that I had it? So, if I have it like this one here, else will happen when both the if and the else if are false. Okay, that's one thing. Okay, if I had it another way, so I'll just let me take this out. Multi-line comment around this. All right, and then I'm going to grab this thing here. I'm going to paste it. All right, and if I had this situation right here, if I had an if and then another if and then an else, the else here will happen when the previous if is false. Okay, so we don't really care whether this was true or false. Who cares? If this one though is false, only then this will happen. Okay, so there is a difference logically whether you write an if, else, and then, or if you write if, else. Just so you know. Okay, so that's that. And that's pretty much your review from last time. Okay, so now you know. We've reviewed it a couple of times. I'm going to go in there and get rid of this stuff. And I'm going to go in there and I'm going to jump to week 4. And week 4, I already did a lecture for the Monday class. So why don't I try to save a little bit of time here and not type the same thing again. So I'm going to copy this. And I'm going to leave it in there. Okay, so I'm going to copy this piece, and I'll go here, and today is the 21st. All right, so what we're going to talk about today is repetition, accumulation, finding the min and the max, and let me erase this. Okay. So, I'm going to go in there and I'm going to grab this whole thing here and paste it. And let me try to uncomment this. There you go. Okay. So one thing, just to make sure, since I kind of started messing it up. So notice how my indentation is kind of weird, right? I don't want to see code written like this, okay? If I see something like this, I'm going to take some points off, tell you to fix it and resubmit it. Okay, so if you see a comment saying fix your indentation, what I mean is make sure it's all lined up the same. Okay, I don't really care how many spaces. I mean, preferably 4 spaces, right? So 1, 2, 3, 4, right? But make sure it's all lined up. So everything inside of the main, it's indented, and that's that. So the next thing is, let me tell you about input validation. Okay, so input validation is basically input validation is make sure the user has entered a good value, right? So the user, we're running the program. Okay, when you run the program, it tells you enter an age, and I'm giving it a negative age, which is bad, right? I give it another negative age, and then it stops. Okay, so this is basically kind of a half-assed input validation. I haven't done it right. So what I'm going to do is I want to make sure that the user doesn't just, basically what happened is I accidentally entered a bad number twice, and then my program took it, and then maybe I can break it later on with that bad value. Okay, but what I want to do is I want to make sure the user enters a good value. So ask the user repeatedly to enter a good value if the value is out of range. So it's out of range, if it's less than 0 or bigger than 123, I give it an error message, right? And then ask them again. So if I have an if, when I had this thing as an if, like this, if happens one time. All right, so whether this is true or false, I mean, if this thing is true, which is we have a bad value, we're going to get an error message, but one time. So what I'm going to do is I'm going to leave this here, just so you know what it is, what it was, right? Then I'm going to grab it, and I'm going to paste it right here, and I'm just going to change this to a while. Okay? So, and maybe let's go with a negative age, right? So if it's a negative age, right? I'm going to say invalid age, enter positive value, right? Positive value. And I'm going to do the same thing here. So if the age is negative, invalid age, enter a positive value. Just to keep it simple in the beginning. Okay, run it. And negative age like I did before, but now it's repeating over and over and over and over until I get a good age. So there you go, 11. Now we're good. Okay? And just like we had an OR in there with the other one, so you can say OR if my age is bigger than 123, I can do the same thing for my while. Alright, I just change this thing to basically the same thing as I did with an if, with an OR in there, and this loop, which is the while loop, will happen as long as this is true, as long as we have a bad value. Okay, so this one happens, while happens until the conditions are false. All right, so it's going to keep going and going and going. So let's try it with the negative and positive values. So -9, now really big value, now another small value, now another big value, and then finally when I give it a good one, it stops. Okay? So that's one practical application of a while loop, right? Input validation. Okay. Any questions? So the while is basically just like an if that happens multiple times. So the next thing is, let's say I want to do this. And I'm going to take this out. I'm going to take these out, comment this out. I'm going to comment this out too. Okay, so now the next thing that I want to do is I want to show the numbers from 0 to 10 in increments of 1, right? So in other words, I want this thing to start at 1, go to 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So it starts at 1, ends at 10, and my increments are 1. Okay? So you know how many times this thing is going to show, or you know how many, if you know how many times something is supposed to repeat, if you know where it's going to start or where it's going to end, and if you know what the increment is, that is a good candidate for a for loop, right? In other words, you know how many times the thing is going to happen, like in this case. So I go and I say, all right, I'm going to say for int, oops, wrong syntax. So for int numbers, or let's call it number, is equal to 1. Numbers, or number, is less than or equal to 10. And then number is equal to number plus 1. Okay? Then I'm going to go in there, let's throw some curly brackets, and I'm going to do a cout number equals number and del. Okay? I run this thing now, and you can see that it shows me the numbers from 1 to 10. Okay? So this is my start. This is the start. This is my stop. And this here is my step. Okay? So this is my step. Okay? So again, you know how many times the thing is going to happen, you know where it starts, you know where it stops, you know what the step is. That's a good candidate for a for loop. Okay? I can make this loop go, let's say I want to show the numbers, another one. I want to show the numbers from 5 to 10 in increments of 1. Alright, I'm going to grab this thing, copy it. This time, this thing is going to start at 5. Right? It's still going to go to 10. It's still going to be in increments of 1. So I run it again. And that is this piece right here. Right? 5, 6, 7, 8, 9, 10. Okay, so that's this. So let's do another one. So I want to grab this thing. I'm going to copy it. So now what I want to do is I want to show the numbers from 0 to 10, but I want to do increments of 2. Okay, I change this thing to 0. This stays as 10, and I'm just going to change my step to 2. Okay, so by the way, I can also write this as number plus equals 2. Right? Whether I write it this way or this way, same thing. It will accomplish the same thing. Okay, run it again. So now I should see 0, 2, 4, 6, 8, 10, which is this piece right here. Yes? Now I can also make this thing go backwards. So I'm going to get it. I'm going to paste it in there. Now what I want to do is I want to show the numbers from 10 to 0 in, I don't know, in increments of minus 2. Right? So it's going to be 10, 8, 6, 4, 2, 0. So starts at 10, goes on while it's greater than or equal to 0, and the step is minus 2. Okay, run this again, and that's this piece right here, 10, 8, 6, 4, 2, 0. Any questions? We got it? Okay. So this is basically, these are for loops, right? So you can have it count by +1, you can tell it count by +2, you can tell it start at 0, start at some other number, you can tell it go backwards, which is basically count by -2, or whatever number you want. So you can also have nested loops. All right, so let's do a nested loop. Nested loop. And you're not going to have to do a whole lot of this. There might be a few assignments, maybe a couple in the whole semester, but you know, it's a little bit more advanced, so I'm not going to go too much in depth in it. I want you to be more comfortable with the basics. So let's say I'm going to have some kind of a variable I, which is equal to 0. I is less than 3. And then I'm going to say I plus plus, right? Which is the same way as whether it, like, instead of I plus plus, I could have done I plus equals 1. I could have also done I is equal to I plus 1. Okay? And in other words, what the I will do is I is going to be equal to 0, 1, 2. Right? Those are my values of I. Inside this thing, I'm going to have another loop for int j is equal to 0 and j is less than 2, j plus plus. Okay? Which is similar to the one on the top, except this time the values of j are going to be 0, 1. Because it's never going to go to the 2, hopefully. Okay? So, what I'm going to do is, I'm going to show you cout I here, and L, and underneath it, inside this one, I'm going to say cout j equals, maybe I should have showed the I actually here, I, and the j is equal to j and L. Okay, so how is this going to work? This loop here is going to generate values 0 and 1. In fact, let me just run it so you can see it. Okay, so let me zoom in a little bit. Okay, so here it is. So initially I go through this loop and I do the first I is equal to 0. Then I get into this loop and then I do these two values. J is equal to 0, j is equal to 1. Then this loop is done. We go back to this one and now I becomes equal to 1, which is this here. Okay? As soon as that happens, I show you the I is equal to 1, then I go back into this loop again, fresh start, and I show you the j is equal to 0 and 1, right? So this loop happens again. When this loop is done its magic, we go back to the beginning of the for loop, or the next iteration through the loop. Now I is equal to 2, which is the last value that I'm going to be getting, right? 0, 1, 2 are the ones that I was going to get here. And then for that last one, for the I is equal to 2, I also have this inner loop happen one more time. Okay, so just like I could have an if inside of another if using the nested statements, same thing I can do with a for loop. Okay, and you are going to get to have a couple of assignments with this stuff. Okay, it comes into play. Any questions? We're good? Positive? Okay. So these are nested loops and all the different possible applications of a for loop, right? And again, if you know how many times something is going to happen, if you know at what point do the numbers start, at what point do they end, by how much do they increase, use a for loop, okay? Now what I'm going to show you is basically that you could do the same thing that you did with a for loop using a while loop, okay? So I'm going to do it right underneath. Okay, so what I'm going to say here is rewrite the above using a while loop. Okay, so we'll go something like this. I'm going to say, all right, int number is equal to 1. I'm going to say while number is less than or equal to 10. I'm going to throw in curly brackets in there. And why don't I just do this? I'm going to put a 4 in there so you know which one's what. So this is the number from the for loop. This is the number in the while loop. And then at the end, I'm going to do number is equal to number plus 1, right? Also known as number plus plus, also known as number plus equals 1, right? Whether you do it in any of these three different ways, it's the same thing. I personally like this one because it's the shortest. So if you see me starting using this, I'm going to start using that like right here, right? That's why I'm doing it. Okay, so just like I had a start, stop, step, this is my start here, right? This is my stop here, and this is my step. Okay? So If the for loop allows you to write the whole thing on a single line, the while loop requires you to have a couple of extra lines, at least 1, 2 more extra lines. Okay, which is why if you're going to be doing something that you know how many times it happens, it is better code to use a while loop. I mean a for loop. Okay, if you keep using while loops for everything, you know, it's better for you to use for loops if you know how many times the thing's going to happen. So then why don't I run this thing? All right, and here's your for number right here. For goes from 1 to 10, and then you have your while goes from 1 to 10 also. Okay, and I can do the same thing with these other ones. Let's go to let's say this one here. So I'm going to say this time I'm going to say number is equal to 10 while my number is greater than or equal to 0. I'm going to show you this a for here, and I'm going to copy this thing, paste. Now it's a while, and I'm going to have to do the number is equal to number minus, what did I say, 2. Okay, so if I run this thing now, somewhere in there it is. So this is your for loop, goes from 10 to 0. This is your while loop, goes from 10 to 0. Any questions? And you can also nest while loops. You can have a while loop inside of another while loop. It's going to create more clutter. So one more time, if you have the opportunity to use a for loop, use a for loop. Okay? So that's the better programming style, if you want to call it that. Okay, better coding. Okay, so that's that. Okay, so I can have loops that happen as many times as the user wants to, right? So I'm going to go and put this on the bottom. So this is, let's say, loops that happen as many times as the user wants to, right? So let's say we have something like this. I'm going to grab one of these loops here, so I don't have to write it. Okay. Instead of less than 3, I'm going to say less than times. Okay, what is times? I don't know, something I'm going to define right here. So int times, and I'm going to say cout, how many times would you like the loop to repeat? Right, and cn times, and then I can just show you cout I equals I and L. Okay, so if I run this, how many times would you like the loop to repeat? 20 times, and there you go. Goes from 0 to 19, which is 20 times. Maybe you want to show it from 1 to 20. You could just add a 1 in here. Whoops, plus 1. So every time I show the value of I, I'm going to add 1 to that thing. Okay, run it. How many times do I want to repeat? 10 times. Now it's going to go from 1 to 10, right? It doesn't start at 0 and it goes to the actual value that I want. Okay, another way to do this is, instead of writing this here, I can go and I can say, all right, well, I'm going to start this thing at 1, and I'm going to tell the loop to go to less than or equal to times. All right, check again. I want to do this 10 times, and then again it goes from 1 to 10. So as you can see, there's multiple ways to do the same thing. Okay, it's just a matter of you understanding the material and then applying it any way you want. Okay, so when I look at your programs, they should not be the same. Okay, in fact, I've been doing this long enough that if somebody, I have it every semester. Somebody works with somebody and they think that they can slip it by me, and then they turn in the same program from 2 different people, and it might slip by me 1 time, maybe 2 times, but there's 70 assignments in this class, and I'm going to catch you. All right, so don't do it. Okay, it's okay to work with each other, But if you start turning things that have the same variables, the same order of things, it's the same exact solution. Sometimes people even forget to change the comments. It's the same exact comments in the same program. It's a red flag, okay? And that's why I say write lots of comments, explain things to yourself. If somebody copies your program, I know, okay? And it's a very easy way for you to prove that you did your own work, okay? Because you wrote your own unique comments, at least. Okay, so that is a loop that happens as many times as the user wants to, and I can do the same thing with a while loop, right? So I'm going to go in there, I'm going to say while, I'm going to say first I is equal to, whoops, what happened here? Don't tell me it crashed on me again. And this thing. C-line took it. Alright, C-line. For some reason, when I'm plugged into the projector, maybe it's something with the resolution, C-line is just acting up. Alright, so at least we saved it, or it saved it. Okay, so what I'm going to do now is I'm going to rewrite this thing using a while loop. I'm going to say, okay, int I is equal to 1, right? I'm going to say while I is less than or equal to times. And I'm going to put a little 4 in there so we can differentiate between one and the other. Curly brackets, copy this hit here. Throw it in there. Now this is a while. I just got to add a... Well, actually, let me show you a never-ending loop while we're at it. Okay, so this is a for loop. Now we're going to do a while loop. But I intentionally kind of messed it up. Right? Come on. Increase font size. Alright, good enough. Alright, one more. Okay. So, I'm going to run this thing, and you're going to see a never-ending loop. What did I fail to do for this? I didn't tell it to increase the I. So what is it going to do? It's going to show me I is equal to 1 forever. Until I run out of memory, until the program crashes, until the operating system kills the program, right? And it doesn't matter how many things I want to do. I want to do 4. This is a never-ending loop. So I'm just going to go in there. I'm going to stop it. Okay? And I'm going to fix it now. I'm going to go in there. I'm going to say I++. Run it again. So I want this thing to happen 5 times, and you can see that it happens 5 times with the while loop, 5 times with the for loop. Make sense? Any questions? What's up?
How come for the first one it would do it forever? I get why it's only once because you didn't say to add, but like why does it keep going forever?
The reason it was going forever is because I didn't do this here. So basically I'm telling it, okay, start I at 1, go on while I is less than whatever I entered here, which was 5, and it goes in there and says, okay, I is equal to 1, goes back to the beginning. Is 1 less than 5? Yep, okay, show while is equal to 1, okay, go back to the beginning. Is, 1 is still less than 5 forever, right? But when I do this, when I do an I++, what happens is it starts at 1, it shows you the 1, then it increases the 1 to 2, then goes back to the beginning of the loop. Actually, it goes back to the condition of the loop, checks to see is 2 less than 5. Yes, still is. Shows you the 2, increases to 3, same thing until it gets to 5. Is 5 less than or equal to 5? Yes, still is. Still less than 5. Shows you the 5. Now it goes to 6. Is 6 less than or equal to 5? No. Stops. So, and that brings me to the next one. If I do cout, I equals here. So after a while, I is equal to I and del. So what is the value? That's my question to you. What is the value of I below? You gotta tell me. So let's suppose for this case, let's suppose I have said that I want this thing to happen times is equal to 5, right? We already know from the previous run that inside of the loop it's going to show me it's going to show me 1, 2, 3, 4, 5, right? That's this. But my question to you is, what is it going to show me right here? That kind of follows about what I was talking about just now.
So it would keep showing like I forever?
So one more time. Okay, so let's check this out. So it starts at 1, right? Checks to see if 1 is less than 5. It is. Shows you the 1. Then it goes to 2. Then it goes to 3. Then it goes to 4. Then it goes to 5. That's this, right? When it gets to 5, right? It shows you the 5. It goes and it says, okay, now I is equal to 5 plus 1, so it's 6. Goes back to the beginning. It checks to see, is 6 less than or equal to 5? No. Stop with the loop. But guess what? I still has its value from inside of the loop. So when I go in here, what is it going to show me? 5 plus 1 is 6. Okay? So if I run this thing, I want to do this 5 times. See? After a while, it goes to 6. And this is the last value of I for when it's done with the loop, right? So we show the 5, we increase the I to 6. Is 6 less than 5? No. Then exit the loop, but then as soon as you exit the loop, the I is 6. Okay? There's going to be some quizzes in there that's going to ask this kind of stuff. Right? There are some quizzes that I have set up, multiple choice things that are going to ask you, how many times does this thing happen? Just like I showed you, it happens 5 times, okay? Or predict what are the numbers that this is going to show you. Is it going to be 1, 2, 3, 4, 5? Is it going to stop at 5? Is it going to stop at 4? Is it going to go to 6? Right? So I have set up these little questions in the class to make sure that you're getting it. Okay? Does that make sense? So you know what a never-ending loop is, right? You saw that thing that goes on forever. You saw that when you have a while loop, the last value of whatever the counter variable is increased beyond what the condition is when the loop is done. Just so you know. Okay, and this was an example of loops that happen as many times as the user wants them to. Okay? So let's have another kind of a loop now. So since I already showed you a never-ending loop, let me do another one. Okay? So this is while true. So by definition, this is a loop that's true forever. So this is a never-ending loop. Never-ending loop. Okay? And inside this never-ending loop, what I'm going to do is I'm going to have let's just do a little hello. Alright, just so you can see it going. And well actually, why don't I fill up the screen with this thing? No, that's okay. Separate lines. Alright? In fact, why don't I do this? I'm going to say I is equal to 0 here, and I'm going to show you the I. I equals, and I'm going to show you the value of I. So you can see how fast this thing is growing. And by the way, C-line is a smart IDE, which is why it kind of highlights things for me. Right now it's kind of indicating that, hold on, you created an endless loop. Okay? That's okay. I'm ignoring the C-line, right? Because I want to make the example. So in here, I'm going to say I plus plus. Right? So the value of I changes, but so what? The loop, how long the loop is going to repeat does not depend on I at all. So what are the values of I that I'm going to see for this one? 0, then 1, then 2. Is it going to stop at some point? No, it goes on forever. So let's have a look at how quick it goes. So it doesn't matter how many times I want to do this one. This one doesn't depend on that. See? So it goes pretty quick. I'm already at 1,694,000, which only took 2 seconds. So it's going quick. Okay? So that's a never-ending loop. Okay, but let me go back, and what I'm going to do is I'm I'm going to change this thing a little bit. I'm not going to show you the why. What I'm going to do is I want now this to be a loop that goes on until the user enters a specific value. Okay, so I'm going to do something like this. I'm going to have a variable num, and I'm going to ask the user to enter a number. Enter, let's say, -999 to stop. Okay, cn 999, oops, 999 num. Okay, and if I have it just like this and I run the program again, it's still go on forever. It will go on forever. So enter -999 to stop, 999 0 whatever -999. No, it goes on forever. Why? Because it's true forever, right? I can't change that true. It's just there, true. Okay, so how am I going to stop this loop? I'm going to use an if, and I'm going to say if my number is equal to -999, I'm going to do break with a K. Okay, and this one stops the loop here. Okay, so I'll check it. This one doesn't matter. All right, enter -999 to stop, so I'm going to do 9. I'm going to do 999. I'm going to do 0, -999, then it stops. Okay, so what if I go in there and I do a cout high? Okay, my question to you is, from what you've seen so far, will this show if I enter -999? What do you think? That's a yes or no. No, right? Why? Because, like I said, as soon as you hit the break, it stops the loop here. Nothing after it happens. Nothing after it happens. Right? So this will not show. Will not show if I enter -999. Okay? So that's a loop that goes on forever until the user enters a certain value. Another way that I could do this is I can basically rewrite my loop to something like while num is not equal to -999. Right? And then I can just get rid of this here. Get rid of these. Whoops. All right? And it'll work pretty much the same. Okay? So that's that. And let me see what else do I want to tell you. So that's the never-ending loop. Loop goes on forever. Okay. So that brings me to another point about having variables be local and global. That will be, I guess, well, I could have told you about this when we did the ifs, but I'm going to tell you now. So I guess I'll show you an example with an if too. So let's say I have an if num is equal to 0. It doesn't matter, right? Let's just go, yeah, whatever. And I'm going to say int a is equal to 10. Okay? And let me make the num equal to 0. Num is equal to 0. Okay? So the if is true. And then I'm going to go in there, I'm going to do a cout a equals a and L. Okay, notice how C-line kind of marks it with as red. So that means that if I try to run this program, there's going to be some problems, and this is my problem. All right, look at what it's saying. What's the problem? Can you read this? What is this thing saying? Undeclared identifier A. But I declared it. I declared it right here. What is it talking about? What does it mean? It's not. It's undeclared. I declared it, but A is declared inside of the if, which means that A can only be visible, or A can only be used inside the if. Okay, in the if. So the only place that I can use the a is inside my if. If I go and try to use this a outside of the if, no good. Okay? So in other words, the scope of a is the if. Okay? Or another way to say this is a is local to the loop, or to the if. Okay? So what is a local variable? Right? A is a local variable. A is a local variable which can only be used inside of the block, and by block I mean the curly brackets, where it was declared. And that's why it's important for you to know your terminology, right? If you don't know what it means to declare a variable, it won't make sense, right? You need to know what a scope is, you need to know what local is, right? You need to understand these bugs, because in the real world, I'm not going to be there to hold your hand. And same thing, when you transfer to university, I'm not going to be there to hold your hand. I'm not going to be providing hints for your, software development class that has 15,000 lines of code in it, right? Not baby programs that we're doing. So you need to know how to debug your programs. You need to learn the terminology. Any questions? So, okay, so that's one thing. So I can't do this. So this is bad, because a can only be used inside of the if, where it was declared. Okay, so that's one. And the same thing applies when you have a loop, right? If you have like a while num is less than whatever, less than 0, right? It isn't, right? Num is equal to 0 initially, right? And I'm going to do the same thing. I'm just going to copy the whole thing. Throw that in there. I'm going to grab my cout. Throw it at the bottom. And look at what happens. Same thing. Okay? If I try to compile, if I try to run my program, I'm going to get a similar kind of an error right there. All right, cout and L. This is on line 138. This is my line 138, column 23. Right, this will be the column 23. Right, use of undeclared identifier a. So basically the same thing. So a is a local variable which can only be used inside of the block where it was declared. So a is declared instead of the while, and which means that the a can only be used in the while. And yeah, basically the same thing twice. And so the scope of a is the while, and a is local to the while. Okay, so be careful of this. Important stuff, very, very important stuff. Questions? Okay. All right, so you know how to make a loop stop with a break. You know about a loop that can go on forever until the user enters a specific value. You know about the scope of variables, what it means to have a local variable. And now, let's see what else do I want to tell you. Yeah. Okay. So I guess just a little more examples. So what I want to do is, let's say I want to do this. I want to show the numbers like this. I want to show 1, 2, 3, 4, 5, 6. Let's just stop it at 6, right? So you help me out. For int, let's call it j, is equal to what? 1. Okay, j is less than or equal to what? 6. And then what do I do? J plus. And then if I go in there and I say, all right, hold on, this is cout J, well, let's just do it this way, J, and then I'm going to put a little comma after it, and on the same line. Okay, and I'm going to run the program again, and whatever. Maybe I should comment these out, but whatever. I get 1, 2, 3, 4, 5, 6, but I have an extra little comma at the end. I don't want that. What do I do?
Don't you need to take out the comma from the string?
Here, take it out.
Or you have to put end L.
Well, if I do an end L, and I run this thing, what don't you like? Okay, yeah. End L, whatever, 3 times negative 999. Negative 999. Then it shows them on separate lines, but I don't want that. I want to show it like this, except I don't want a comma on the last one. So I want this kind of stuff, except I don't want my last comma to show at all. All right? Any ideas? What did we learn that will allow my program to select between things, or how to do things? Well, what did we do for the previous 2 weeks? Ifs? All right, so why don't I do this? I'm going to tell it this. I'm going to say, okay, if my j is less than 6, show this, right? And I'm going to say if my j is equal to 6, then I'm going to show it with that new line that you said. I'm just going to do \n. Okay, check again. Whatever, negative 999, and there you go. Okay, so you can have an if inside of a for loop, no big deal. In fact, that's the purpose of these. You nest them inside of each other. Okay, you can have a for loop inside of an if. You can have an if inside of a for loop. You can have a for loop inside of a for loop. You can have an if inside of an if. You can do whatever you want, basically. All right, it's a free world. Okay, many ways to do the same thing, at least. Any questions so far? Still good? Okay. So now let's have a look at what else I want to tell you. That's the while loop. Okay, so what I'm going to do now, I guess, is go through these assignments and give you some hints. All right, so first one, 19, is just a couple of sample programs. Type them both, right? Here's your 4. This is program 4. One file, program 5, another file. Type the whole thing up. Make sure it works. Make sure there's comments. All the comments that you see in there, all the gray stuff, gotta be there. If it's not there, I'm taking points off. Okay? Make sure it runs. Put the test run on top of on the bottom of your program. Same thing with the other one, right? Make sure it works. Put it on the bottom of the program. Okay, so that's your sample programs just to get you going. Okay, the next one is some kind of a conversion table. So what we're going to do is, and I have some hints underneath this, but let me do another one. So what we're going for is we're going to have some numbers on the left, and then these are kilograms, and then some pounds on the right. Right? So 1 pound, 1 kilogram is 2.2 pounds. So 3 kilograms or 3 times 2.2, 6.6 pounds, etc., etc., etc. But you don't show every one of them. You show 1, 3. You don't do 1, 2, 3. You do 1, 3. Right? So it's by jumps of 2. Okay. So let's do a little hint on this. So this is your P20 hint. P20 hint. All right, so let's do currency, some kind of a conversion thingy. Pick a currency for me. Huh? All right, yen. Yen to USD. Okay, so 1 yen is 0.089 US dollars. Okay, I'm going to copy this. So 1 yen is equal to this many dollars. Okay, so what I want to do is want to show values of yen, or to show US dollar values of yens from, let's go from 1 to 1,000, and I want increments of 50. So it's going to go 1, 51, right? Let's start at 0. Why not? Why not 0? 0 to 1,000 increments of 50. Okay? So I'm just going to go do this. For int yen is equal to 0, yen is less than or equal to what value? Help me out. No, I'm going for, I want to show values of yen from 0 to 1,000. So 1,000, okay. And increments of 50, yen is equal to yen plus what? 50, okay. So first thing I'm going to do is I'm going to do a cout. I'm going to do yen equals yen and del, okay. And just run this thing, see what happens. I should just stop this thing. -999. All right, so there you go. We got the yen from 0 all the way to 1,000. Okay, in increments of 50. All right. So now what I got to do is I got to calculate the dollar. So what I'm going to do is I'm going to make another variable. Well, let's call it the double this time. Double US dollar. Okay, and then my US dollar is equal to my yen times this number, 0.089. Okay, and then after this, I'm going to show you the dollar. So this is dollar now. USD equals USD. Okay, run it again. And I gotta enter a bunch of stuff here. -999. All right, so you can see some stuff in there. So you can see 0 US dollars is 0 yen, $50 is like 50 cents, or 50 yen is like 50 cents. Okay, so maybe I should add a little space in there. And I'm also going to take out that CN that I have in there. I'll leave it. Okay, so the next one, let's just run it one more time. All right, so it looks like this. Okay, but now the next thing that I want to do is, because look at the assignment. The assignment is actually asking you to put the labels on top, not kilograms equals and then pounds equals. So I just want to put the labels all the way on top. What I do, I'm going to take this stuff out of here. All right, this, I'm going to put cout right here. I'm going to say this, yen, a little space. And then I'm going to put the dollar next to it. And if I spaced things the right way, maybe you're going to see something that's close to right. So if I run it, whoops, semicolon, and del, try again. Oops, 9, -999. All right, so it looks all right, kind of. Well, maybe I need to add a little extra space, and I will do that. But notice something that's happening. Notice how there's a shift right here. All right, so I go here. Here I'm showing one digit. Then I show 2 digits. As soon as I show these 2 digits, that forces this column to be shifted 1 to the right. Then as soon as I go from 2 digits to 3 digits, that forces this column to be shifted 1 to the right. And then when I get to the 1,000, similar thing happens. I go from 3 digits to 4 digits, and that forces this column to be shifted 1 to the right. So there's a couple ways for you to fix this. And that's in the hint. If you look at this here, you have to include IO manip, and then you have to do the set W business. So I'm going to go back in there, CLion, IO manip, it's already included, and I already need this for the set W, right? Where's the set W? I'm going to put it right here, set W, and I'm going to tell it reserve 4 digits for the yen. All right, so this is reserve 4 spaces for the yen value. Okay, then if I go and run this thing again, and you got to enter things again, -999. Now you're going to see this thing, it's actually lined up. Okay, you could also tell these things to shift to the left. So if I do it this way, it's one thing. If I do it with just saying left, all right, does it know what left is? Yes. So if I do it with saying left, then it will still reserve 4 digits for this, but it will shift all these, it will align them to the left. Okay, so 9, -999, and basically still lined up, but now the numbers are shifted to the left. That's one way to do it. Another way to do this, and I actually prefer this way a little better, and that is using C notation. So C is the old language which C++ was based on. C++ is backward compatible with C, which means that whatever is in the C language you can use in the C++ language. How are you going to do that? You're just going to include some libraries. So this library right here, the stdio.h, is usually needed for the printf. Okay, so that's why I'm including this. And I'm going to go in there, and instead of a cout, printf. So I do this. I say printf, and I'm going to grab this stuff here, paste it in there. So I'm going to have different syntax this time. Comma yen, comma USD, this, and then I'm going to do a new line here. And in here, I'm going to say %4i, which is basically the same thing as this. Okay, so %4i means reserve 4 spaces for the yen value, and then %.2f basically means, so %i, let me write it here. So %4i means reserve 4 spaces for the yen value, and when I say %.2f, that means round the USD value to 2 decimal digits. In other words, see how here I have 4.445? I'm actually going to round this thing to 0.45 because of the %.2f. Okay, run again. Keep your fingers crossed. 9, -999, and there you go. So similar to before. You can also do the align left if I just do minus. All right, and if I run this again, 9, -999. Now you're going to see that it looks even better. Okay, so these numbers are left aligned. We reserve 4 digits for them. Okay, that's how you do it with the minus. Okay, personally I like this way better. I like the printf notation better than the cout because it allows me to easier line things up with less typing. I can just say, all right, well, %4i, and that replaces these two things. If I wanted to round things in C++, I have to do like 3 separate lines of code to get the thing rounded. In C, I just do %.2f, and that rounds it to 2 digits. Okay, so that's your hint for P20. And 21. Okay, so this is your hint for 21. So go in there, and this is P21 hint. See how many more I have left. Four. Oh, I got a few more out of the way. All right, so 21 is requires you to do something like this. So you have to show all these different characters. All right, so you're going to show the character exclamation, then the quotes, then all these other ones. There's some numbers in there, then there's some uppercase letters, some symbols, lowercase letters. How are you going to do this? You're going to use an Ascii table. Okay. What is the Ascii table? The Ascii table is a table with numbers representing every symbol on your keyboard. So if you zoom in, you're going to see that 33 is the exclamation, 34 is the quotes, uppercase A is 65, uppercase Z is 90, lowercase a is 97, and lowercase z is 122. So what the assignment is actually asking you is to start at this one, which is the 33, and show all these other ones all the way down to this last one, to the tilde. So you're going to start at 33, you're going to go all the way down to 126. Okay? So what you need to do for this is, first you're going to have to set up a loop that goes from 33 to 126. Then you have to figure a way to convert each of these numbers into a symbol. Or you're going to convert the ASCII number to a character. So how does that go? So let me do this. So I'm going to go in there. So let's say I have cout. What was my ASCII for A? Lowercase a is 97, right? So first what I'm going to do is I'm going to show you just the number 97, right? And L. Okay. Then what I'm going to do is I'm going to do a cout char 97 and L. Okay. What is char 97 going to show me? This thing shows me the A, right? So lowercase a, which is, ASCII 97. So basically you're telling it, convert the number 97 to character, and it will know to show the little a. Okay? So if you don't believe me, let's run it real quick. And I'm tired of entering these things. Negative 999. Alright, so you can see that 97 and A are right there on the bottom. Alright, exactly what I said. So the next thing is, let's say I want to show the letters from A to, I want to go and I'm going to show you from A to L. Right, so I'm going to show A through L, and I want to show them 3 per line. So A is 97, L is 108, 97 to 108. Okay, 97 through 108. Okay, and you help me with the loop. So for, let's make a variable int ASCII. What is it going to be equal to first? 97, right? And then it's going to go on while it's less than or equal to 108, right? ASCII less than or equal to 108. And then I'm going to say ASCII plus plus. And then in here, what I'm going to do is I'm going to say, all right, cout, let's just show the ASCII with a little bit of space after it. So it's going to show a bunch of stuff on the same line. No new line at the end. Okay, let's try to run this. And the annoying input, 9, negative 999. So it shows me these, 97 through 108. Is that what I wanted? 108, yeah, I did.
Oh.
Yeah, so I wanted to go from lowercase a through L, right? I'm not doing the whole thing, so I'm doing some of it for you. Okay, so, all right, but this is all on the same line, and these are numbers, so I'm going to take this out, and instead of ASCII, what I'm going to do is I'm going to put char ASCII, just like this. Okay, run this thing again, and now instead of numbers, I should see the letters, the lowercase letters. Okay, 9, -999. All right, here's your letters. Okay, which is fine, but I want to show them, let's say 4 per line. Okay, so show letters A through L 4 per line. So here's the approach. What I'm going to do is I'm going to count every letter shown. Okay, in order for me to do this, I'm going to do count, some kind of a variable, count equals 0. And every time I show a character, so every time I do this, that shows me one of these characters. Okay, as soon as I do that, I'm going to say count plus plus. That counts every letter shown, right? So it's first one is 1, then it's 2, then it's 3, then it's 4, etc., etc. Okay, so if I count 4 letters, if count is equal to 4, then I'm going to insert a new line, which is cout and L, and restart counting. Count equals 0. Okay, so you count 4, you show a new line, we restart counting, so the next 4 letters you show, it restarts counting. If I don't have this here, what is it going to do? Well, let's look. Run. When in doubt, test the program. 9, -999. It works for the first 4, right? So it counts 4, shows you the new line. Then what happens to count when I show the E? What is the value of count? 5. Yep. Then it goes 6. Then it goes 7. It never goes back to 4. So in order for me to make it go back to 4, is I got to tell it, all right, hold on, restart counting. Okay, and if I do that, then 9, -999, and there you go, 4 per line. Okay, so that's your hint for P21. Questions? Okay, next one, 22. Sum of numbers from 150 to 250. I actually have the hint underneath it, so I'm not going to type this up. But basically, here's your example of how you're going to be summing numbers from 10 to 20. Right? You make a variable sum equal to 0. Right? I is equal to 10. And then sum is equal to sum plus I every time you go through the loop. So that way you're going to get all the numbers from 10 to 20 including and their sum. Okay? Any questions? Got it? Hopefully. Okay, next one. 23. Okay, so this one is write a program that accepts the integers from the user and tells how many of the numbers were odd or even. The program should stop asking for integers when the user inputs is 0. Okay, so let's do this. This is your P23 hint. P23 hint. So basically, let's make a loop while true, right? And you're going to have the user enter some kind of a number, cout, enter 0 to stop, right? And then you do cn, the number, okay? And if my number is equal to 0, I stop the thing, break. Okay, and then I have to count if the things are, odd or even. So, int count even, right? The way you check to see if a number is odd or even is if any number modulus 2. Remember how modulus 2 can possibly generate only 2 digits. It can either make you a 0 or a 1. So if you have a modulus 2 and it comes out equal to 0, that is even, all right? Then any num is even, okay? So if num modulus 2 is equal to 0, then you count even. All right, same thing with the odds. Okay, so when you're doing these assignments, try not to look at the hints. Okay, I'm showing you way too much, but that's just in case you get totally stuck and you can't figure it out. Okay, if you are relying on the hints to solve these problems, you're not going to make it in the next programming class. Okay, and if you somehow make it in the next programming class, it's not going to be fun for you when you transfer. Okay, so make sure that you develop the problem solving skills, and the way you do that is by just go at the problem by yourself without looking at the hints. If you can't figure it out, then maybe have a look at the hint, and I would even encourage you to come and see me or send me a question then before you look at the hints. Okay, and if you don't want to do that, then look at the hints. Okay, but do not rely on the hints too much. If for some reason, let's say, all right, I don't know how to do this, I'm going to look at the hint. The hint's going to help me write the program. What I will do is I'm going to close the program, put it away, rewrite the whole thing from scratch without looking at the hint. Okay? That is not to say that you're not okay. It's not okay for you to look at the old programs. It's totally okay for you to look at all the other programs up to this point so that you can see how you did things and so that you can reuse your old code for the new things. I'm totally okay with that. But as soon as you encounter a new problem, a new solution for you to come up with, don't rely on the hints. Don't look at it's like if you have a math class and you have all the freaking solutions in the back of the book or whatever, you have a solutions manual, you're never going to master the math concepts if you just always rely on the solution to do it, for you. Okay? So you got to problem solve by yourself. That's the count odd and even. And last but not least, this one's very important, and I have a hint for it too. And this one is similar to 25, and the hint is in here. Okay, I'm almost done. So the hint for this is basically like this. So it goes like that. You're going to make some kind of numbers. So you're going to have these variables. How many numbers you're going to enter, the number that you're going to be entering, and some kind of a variable smallest. Okay. The way you solve this is what you have to do is you have to make smallest equal to the first number that the user enters, right? So the user is going to enter as many numbers as they want. How do we know it was the first number that they're going to be entering? Well, the first time we go through the loop, I is equal to 0. Okay? So if I is equal to 0, make smallest equal to the first number. So smallest equals the first number when I is equal to 0. And then after that, what you have to do is you have to compare smallest to every other number after the first. So let's say they enter 4, 3, 2, 1, 0. Okay? The first time you go through the loop, smallest is equal to 4. Second time you go through the loop, you're going to compare 4 to 3. Is 3 less than 4? Yes, it is. So now smallest is equal to that number. So now smallest is equal to 3. Then you go through the loop again. The user enters the next number, which is the 2. Right? It's I equals 0 is not true because that's not the first time we're going through the loop. Right? We check to see if the number is less than smallest. Smallest was 3. The new number is 2. Is 2 less than 3? Yes, it is. So now smallest is equal to that number. Okay? Any questions? And it's the same magic that you have to do for 25. Okay? So 25 is pretty much the same kind of thing, except you don't know how many numbers in advance. So 24 is you ask the user, how many numbers do you want to enter? They say 4. They enter 4 numbers. In this one, you tell them, all right, keep entering numbers, and when you enter the -999, then it's going to stop. Okay, but it's the same logic. You're going to make smallest equal to the first number that they enter, which is basically when I is equal to 0. And what is I? I is going to be some kind of a counter. I starts at 0. Every time I go through the loop, I increase I by +1. Okay? So that's it. That's all I have for today. I'm going to post the notes and the video for you because these people are rushing because I went over. And yeah, sorry for keeping you longer than I was supposed to by 10 minutes.